Now I will discuss about the ionic radii. Ionic radii. What is ionic radii? The effective distance from the nucleus up to it has an influence to form ionic bond. What is the meaning of this sentence? Suppose take an ion, that is your Na plus. When it come in contact with the Cl minus ion, then there will be a ionic bond formed in between the Na plus ion and Cl minus ion. The Na plus ion attract to the Cl minus ion, and at the same time Cl minus ion also attract the Na plus ion. Suppose sodium ion present at that position and chlorine minus ion present at that position, and they form an ionic bond. When the Cl minus ion come to the closure of Na plus ion, then the attraction will be more. When Na plus ion come to the closure of Cl minus ion, then also there is a more attraction between Na plus ion and Cl minus ion. Suppose at this point the attraction between Na plus ion and Cl minus ion is minimum. At these 2 points, this is the maximum distance at which the Na plus ion and Cl minus ion influence least attraction force to each other. Suppose I want to take the Cl minus ion and away from the Na plus ion. That means I want to move the Cl minus ion towards the right of this point. Then what will happen? There is a decrease in the attraction of the Cl minus ion. As a result, they are unable to form the ionic bond. The Na plus ion have a capacity to attract the Cl minus ion up to a certain distance. After that distance, the Na plus ion do not influence the attraction force to the Cl minus ion, and also the Cl minus ion do not influence the attraction force to the Na plus ion. This is said to be your effective distance. That effective distance is called ionic radii. That effective distance is called ionic radii. This can be counted from the nucleus. Suppose I want to calculate the ionic radii of Na plus ion. This is your nucleus of Na plus ion. Up to at a particular distance at which the Na plus ion will experience force to the Cl minus ion and able to form the ionic bond. This effective distance is called ionic radii. The ionic radii have two generalizations. The ionic radii have two generalizations. The ionic radii have two generalizations. Point 1. The ionic radii of positive charge species, that is your cation having less than from its parent atom. How it is possible? Let me explain. Suppose take sodium and sodium ion. Suppose take sodium atom and sodium ion. The atomic number of sodium is 11. If I want to draw the electronic configuration of sodium, then this is your nucleus. This is the K cell having 2 electrons. This is the L cell. This is the L cell having 8 electrons. This is the M cell having 1 electron. This is the electronic configuration of sodium. Now I want to draw the electronic configuration of Na+. Na+ having 10 electrons. That means in K cell 2 electron, in L cell 8 electron. No electron present at the M cell. In case of sodium, the resistance considered from the M cell. In case of sodium, 11 electrons are present, and these 11 electrons are tightly binded by the 11 protons. In case of Na+ ion, 10 electrons are present, but there are 11 protons are present. If I want to calculate the nuclear force per electron, then in Na+ ion, the nuclear force per electron is more as compared to the nuclear force per electron in case of sodium atom. That means here more nuclear force for 10 electrons as compared to this 11 electrons. So the more nuclear force attract the valence electron towards more. As a result, the distance will decreases as compared to this. Remember, more is the number of proton, more is the nuclear charge. More is the nuclear charge, then more is the force of attraction of the nucleus to the valence electron, and it attracts the valence electron towards itself more. As a result, the radius will decreases. Here no doubt 11 proton, here also 11 proton, but here this charge will distributed among 11 electron. But here the nuclear charge arises due to the 11 proton distributed among 10 electrons. There is a 1 electron short in Na+ ion. As a result, there is an increase in the nuclear charge for 1 electron. And the nucleus withdraw the valence electron more as compared to this nucleus. As a result, the radius will decrease. So we can write the ionic radii of positive charge species, that is cation having less than from its parent atom, because the effective nuclear charge for electron in case of cation increases, which decreases the radii. This increase in effective nuclear charge for electron is due to loss of electron in cation. Similarly, if I want to think about the radii of an atom and an anion, suppose take chlorine having 17 electron, in K cell 2 electron present, in L cell 8 electron present, in M cell 7 electron present. Suppose I want to think about the Cl minus. There are 18 electron present in Cl minus ion. In K cell 2 electron present, in L cell 8 electron present, in M cell also 8 electron present. Here 17 electron is attracted by the nuclear charge due to 17 proton. Here 18 electron is attracted by nuclear charge due to 17 proton. That means here the nuclear charge per electron less as compared to this. As a result, this nucleus influence less nuclear force to the valence electron as compared to this valence electron. Since there is a less influence of nuclear force to the valence electron, as a result the electron away from the nucleus more as compared to this electron, which concluded that the radius in Cl- ion is more as compared to the radius of chlorine atom. So we can write another point: the ionic radii of negative charge species, that is your anion, having more than from its parent atom, because the effective nuclear charge for electron in case of anion decreases, which increase the radii. This decrease in effective nuclear charge for electron is due to gain of electron in an ion. So we can give an example: radii of Cl- ion greater than radii of Cl. Similarly, we can give an example in case of cation: radii of Na is more than radii of Na plus. Finally, we concluded that the radii of a cation is less than the radii of an atom, while the radii of an anion is more than the radii of an atom. Now I want to explain the variation of ionic radii along a group. Variation of ionic radii along a group. The ionic radii of the elements, the ionic radii increases from top to bottom due to addition of new cell. That means we can conclude that Li plus having less ionic radii than Na plus having less ionic radii than K plus less ionic radii than Rb plus having less ionic radii than Cs plus Cgm plus, because in Li plus the number of electron is equal to this two electron is filled in K cell. In Na plus 10 electron is present. This 10 electron filled in K and L cell. If you think about potassium ion, then the electrons are filled in K, L, M. Like that you think about another ions. There is an increase in the cell. That means there is an increase in the radii of the ions. So we can conclude it when we move from top to bottom of a group, then the ionic radii increases due to addition of new cell. Suppose I want to ask a question: N3 minus O2 minus, next is your F minus Na plus Mg2 plus Al3 plus. Arrange the following according to the increasing or decreasing order of the radii. then which having more radii and which having less radii?
In N3 minus 10 electron present, in O2 minus 10 electron present,
in F minus also 10 electron present, in Na plus also 10 electron present, all the ions carry 10 electrons. So these ions are called isoelectronic ion. Isoelectronic ions. Suppose I want to compare the ionic radii. Then how can I will able to compare the ionic radii? For this case, we generally calculate the nuclear charge, that is your nuclear force. In which case the nuclear force is more. If I can identify the ions which having more nuclear charge, or that is your more nuclear force, then that ion having less ionic radii. Because more is the nuclear charge or force, less is the radii. The nuclear charge or nuclear force generally depends upon the number of protons. So I want to calculate the number of proton in all the ions. Here the number of proton is just 7. Here 8, 9, 11, 12 and 13. These are the number of proton and these are the number of electrons. Tell me in which case the effective nuclear charge, that is your nuclear force, is more for 1 electrons. Obviously here in case of L3 plus ion, 13 proton is used for 10 electrons. For 1 electron, here the nuclear force for 1 electron, the nuclear force is more in case of L3 plus, because L3 plus having 13 proton but it have 10 electrons. That is L3 plus having more nuclear charge as compared to N2 plus, as compared to Na plus, as compared to F minus, as compared to O2 minus, as compared to N3 minus. So L3 plus ion having less ionic radii as compared to all. That means we can write this is the order. This is the decreasing order of the ionic radii of the ions. In case of isoelectronic species, the ions which having more nuclear charge having less ionic radii. Since Al3 plus having more nuclear charge for electron, so it having less ionic radii. Then what is the meaning of isoelectronic species? What is the meaning of isoelectronic species? These are said to be isoelectronic ions. The species which having same number of electron but having different nuclear charge are called isoelectronic species. The species may be an atom or ion or molecule. Means isoelectronic species may be atom or ion or molecule. Take an example, H2O. H2O having 10 electron but it is a molecule. Similarly, neon having 10 electron but it is an atom. It is your atom, this is your molecule and these are the ions. All the ions and the molecule and the atom having 10 electrons, so these are called isoelectronic species. That is all about the ionic radii.